Hi, good evening. Yeah, this is the Math Simpler. Yeah, today we want to talk about something on set theory. Yeah, today we want to learn about set theory. When you hear something about set, who can tell us what is a set? Just from real world experience. Set theory. Set theory. A set, the normal set we know, the one for geometry. A set is a collection of objects sharing a similar property, like the one for geometry has compass, the rulers, etc. And their property that makes them together is that they are for geometry drawings. That is the property that makes them be inside that set. Like they are items used for specific purpose. And there is no difference with the same set we want to talk about. A set is just a collection of objects. A set is just a collection of objects sharing some properties or characteristics. Yeah, collection of objects sharing a particular property. That is the definition of a set. A collection of a well-defined and distinct objects grouped together. These objects are well-defined and they are also distinct. Meaning, the object for something to be called a set, this object must not be the same. They must be distinct and well-defined. Meaning, they are well-defined for a particular purpose, where the property issue gets in. That is a set. So, we have in real life, we have a class. A class has subjects, and the subjects are math, English, Kiswahili, etc. So, when you want to regard this subject as a set, these are set of subjects in a class. And all sets are represented in a curly brace. A set must be represented in a curly brace. This curly brace brackets. So, that's curly brackets. All sets are written inside a curly bracket, which is this one here. For example, we have a set of vowel sound, vowel letters, like let that set be A. It's a set of vowel letters A, E, I, O, U. also another set, another type of set. That's all. Those are examples of sets. You have to know a set is a collection of objects sharing a particular property. And the set itself should be well defined, and it should be distinct also. So, to define a set is just a collection of objects with a particular property, which are well defined and distinct. That's okay. The next thing is set representation. Representation. There are two ways in which we can represent our sets. The objects within a set are called elements. Elements of a set. Like we have A, B, C, etc. These are elements of alphabets. Alphabets. So the objects of a set are known as elements. So the two ways of representing a set, number one, we have by listing. You can represent your set through listing, just making a list. For example, we have a set of real numbers. Real numbers to be 1, 2, 3, -1, -6, etc. This is a set of, this is a list, just making a list. Then we have another method of representing a set called set builder notation. And this is the one which is commonly used, the set builder notations. A set builder notation have a set notation in curly bracket x. X follows t. For example, this one here, it means the set A has elements of x such that those elements follows a particular property. E.g., we have set of positive numbers. Set of positive real numbers to be the set x such that x is greater than 0. This is what we call a set builder notation, meaning this is a set of numbers above 0. When we start with 1, 2, 3, 4, etc. So this one is called set builder notation, and this one is called the listing method. Those are the two ways in which our sets can be represented. I hope you understand everything. It's very easy. The topic is very easy. And for someone who still thinks that these are rocket science, these things are very easy. And sets are just normal things we do. When you sit in a class, that's already a set. Because a group of students doing a specific thing. What you are doing in a class is studying. Studying becomes the property. And those who are sitting there doing the studies become the element of that class. So a class is a collection of a student with a purpose of learning. So that is it. So the next thing we are going to do, we are going to look at the examples of sets. Examples of sets. Number one, we have the finite sets. Finite sets. When you hear the word finite, what comes to your mind? These are countable. Countable. Meaning a finite set, these are sets with countable number of elements. That is a countable set. Then the next one we have infinite. Infinite. Finite, infinite. This is the opposite of each other. Uncountable. Then we have the next one is null. Null sets. Null sets is just an empty set. Just a set with no element inside. And this empty set is always a subset of all sets. Yeah? These are the examples of sets. We have types of sets. Before we go to type of sets, we want to have a very good example here for you to understand this issue of sets. We have days of the week. That is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. This is a set. And this set is a set of days of the week. Properties of this set. Number one, because we already have 7 days in a week, this set becomes a finite set. The other thing, the set has been represented by listing. The property that this set is sharing is that all of these elements represent the days of the week. That's the property. So this qualifies to be a set. I hope you understand. In case you don't understand, you are free to ask any question. Yeah, in case you are free, you don't understand, you are free to ask a question. Anyone? Okay. Silent means everything is okay. Let us go ahead to discuss something on types of sets. We have types of sets. Number one, we have something called singleton. Singleton, when you hear the word single, means one. This is a set with only one element. Singleton set is a set with only one element. And for example, we have a set A having element 2. The subset of this set are 2. This set has 2 subsets. Number one is empty set. Another subset is the set itself. A set is a subset of itself. We'll go to that one as we continue. The next one we'll have here is something called empty set. We had already discussed it. Empty set. That is a null set. Set with no element. Another one we had also discussed is finite.